Good morning, everyone. Can you hear me?
Yes, sir.
Yes,
My screen is Hello, my screen is visible to all.
Yeah, yes.
Yes, sir.
yes, sir.
Okay, okay. So we are starting our today's session. Myself, Manish, welcomes you all for today's webinar on intelligent cloud and intelligent edge. So we will start our today's session intro part about today's session. Today's webinar is organized by ETC community, that is Emerging Technology Community, and sponsored by Synergetics. Our ETC community is open for all people who are interested in emerging technologies and Microsoft Cloud technologies. You just need to follow our community groups, which is Emerging Technology Community, Azure Tech Community Pune for Pune guys, Surat Emerging Technology Community for Surat guys, Azure Tech Community Nagpur for Nagpur people, Artificial Intelligence AI on Microsoft platform who are interested in AI technology. You need to just install the Meetup app on your phone and follow our communities so you will be updated about our events, meetups, webinars and workshop. This is a small code of conduct which you need to follow. Please note you can't take screenshot of the presentation and can't do read screen recording. If you need recording, then simply subscribe our YouTube channel. We will sharing the YouTube channel link in the chat box later. Today's session is all about intelligent cloud and intelligent edge. Agenda for the today's session is Azure Edge Zones, common application scenarios, local data processing, real-time IoT and AI analytics, new frontiers for developers, we believe that today's webinar knowledge takeaway will be improve app performance and data control, deliver better mobile experiences with 5G network, boost private edge performance with 5G networks. Today's speaker for the webinar is Mr. Navjoti Baruwa. He has 15 plus years of experience in field of software development, consulting and architecting. Currently, he is extensively working on Microsoft Cloud Platform in the field of AI and application modernization and IoT. He is a Microsoft certified trainer, completed various Microsoft certification in the past. He is currently working with Synergetics as AVP Technology. Our courses calendar from which anyone certification course you can do with the flat 50% off. These are our courses, Microsoft Azure certification courses. This is our next month webinar series calendar, entire ETT webinar calendar. Please follow our meetup groups so you can update it with this webinar calendar and workshops also. The webinar is on 12th June, the complete guide to Microsoft Power Platform. The speaker will be Mr. Om Prakash Pandey. So join us for the free webinar to exploring Power Components. Your feedback is important to us and we request you to submit your feedback form after the session. We will be sharing the form link in the chat box later. Now I would like to hand over the mic to Mr. Navjoti, sir. Thank you everyone once again. Sir, you can proceed with the session.
Yeah, thank you, Manish, for introducing me. I would like to welcome all of you for today's webinar. Good morning to all. Hope everyone is doing well in this pandemic situation. So let me begin by presenting my PPT for today's webinar on intelligent cloud and intelligent edge computing. So before I begin this particular webinar, so let me set the context what we are going to explore in during this 2-hour session. We have been talking about the multiple kind of workload. Maybe sometime we talk about data and AI, sometime we talked about analytics, sometime we talk about application modernization, sometime we talk about infrastructure related. The workload are typically what is being run on cloud platform. So when I say cloud, at this moment, I'm referring to the Microsoft cloud only. So we have come across an idea of intelligent cloud because the cloud is going to give us a whole lot of computing power along with a lot of intelligence services that we don't need to go and do things on our own. That would be done automatically by the services which is available on the cloud platform. And our workload is, typically go and keep subscribing them one after another to make your workload more customer relevant in today's context. And we all of us aware of this cloud platform is an intelligent platform. So as I said, it could be architecting or design for different workload, but at the end of the day, we get a whole lot of stuff from the cloud itself. But having said that, moving forward, do I really have to go to the cloud to get all kind of intelligence computing that I'm talking about? Why can't you get it from the on-premises? Why can't you get it from the near real time? Or maybe, why can't you get it from a device or a particular appliance which is sitting next to me? Rather, we go into the cloud. So can we really bring back those intelligence computing from the cloud back to the on-premises? And that is the questions the people start asking in today's context. The answer is yes, we can bring back those intelligence cloud computing capability from the cloud platform to back to the on-premises. And that is what the moot point that what we are going to discuss during this 2-hour webinar. So again, I'm saying how we can bring that intelligence computing that I'm talking about back to the on-premises. We talk about edges. Edge is all about on-premise. Edge is all about some computing instance running next to your devices who's supposed to do a whole lot of job within a particular domain of application. So The learning objective with this particular session would be primarily three. What are the intelligent cloud and intelligent edge? Powering innovations from the cloud to the intelligent edge, and IoT plug and play. Now there are multiple, the way that we can talk about how we can get cloud computing, the cloud intelligence computing back to the on-premise. But here we are going to talk about some implementation related to Internet of Things. And under the intelligent edge, I'm just picking up IoT plug and play. How quickly I can make use of plug and play features in order to IoT device working back to the cloud and delegating the task from cloud to on-premises. So if you go by the definition of intelligent cloud and intelligent edge, the intelligent cloud is all over today. We get to see ubiquitous computing. So we can see this computing all over. So cloud computing is not something new to all of us. We have been listening for quite some time. We have been using for quite some time. We have been exploring the capability of cloud computing for quite some time. That is something everyone aware of. And primarily today, the public cloud is more popular. So Microsoft Azure is one example of the public cloud. And we get a whole lot of workload on top of the public cloud like Microsoft Azure, including artificial intelligence technology. So in today's context, the artificial intelligence technology is more powerful because you infuse AI capability into the applications to replace the human interactions typically we do in a traditional process. And that need to be taken over by the AI technology by infusing them into the existing application, or maybe creating a complete modernized application who can basically deliver the AI capabilities. So we are just talking about the AI is one of the computing on the public cloud, but there, as I said in the beginning, there may be multiple workload that I can talk about. But AI is so emerging at this moment. So I just picked up the AI is one of the working area for this particular webinar. Now, back to the intelligent edge is continually expanding a set of connected system and device that gather and analyze data close to your user, the data and both. Let me just quickly explain what this particular statement is trying to tell us. In the beginning, I said, yes, we know, everybody knows the cloud is full of computing resources, computing sources, intelligent computing sources that I can say that. But do I really have to go every time to the cloud to subscribe to those intelligent computing that I am referring to? The answer is no, not. You may not go every time all the way to the cloud to get those intelligence computing. You can get it on premises. You can set up the environment on premises and you can bring back those intelligence computing back to the on premises. And then we talked about edge computing, that the edge become intelligence like cloud. So that is what we say. Suppose if I have an IoT device, hypothetically that I am just trying to give an example, the IoT device or a sensor is going to read a temperature of a particular building or a particular room within a building. And based on the collected data, based on the collected temperature, we need to take a decision. For making a decision on the data, I need to go and probably apply some kind of analytics algorithms. So do I really have to go back to the cloud to run those analytics algorithms in order to take a decisions on the incoming data from the underlying temperature sensor? The answer is no. Probably we can take a decisions at the edge itself, the on-premise itself, or the near to that particular sensor from where the data is being collected. Rather, we go all the way to the cloud to execute those intelligence, the analytics engine. Rather, we can do it on premises. So that is the point what this second statement is trying to tell us. Intelligent edge. So net, one thing is coming clear at this moment, that whatever we can do on the cloud, probably 50% or maybe 40 to 50% of that particular intelligence computing, we can do it on premise in today's context. That is the statement made by the entire presentation that I'm going to deliver today. So when you continue with that, user gets a real-time insight and experience delivered by highly responsive and contextual aware apps. Combined the virtually timeless computing power of the cloud with an intelligence perspective device at the edge of your network to create a framework for building immersive and impactful business solution. So you combine, it is not just everything that you do from the on-premise, you combine, which you feel relevant that we need to go and do it on the on-premise, which you feel that, going all the way cloud would take some time to make a decisions. I need a quick decisions to be made. So can I do this on premise on the edge? But there are certain things cannot be done in on premises. We need to go back to the cloud. So it's all about collaborative working between on-premise and cloud to make your system really robust, what people are looking up to in today's context. Because the today's applications, today's requirement from the different verticals is really complex. And not only that, the people want the quick response. People want quickly the things to be executed. The people want a quick result. They don't want to wait for a long to get a result back on their system, back on their page, back on their application. So we need to collaborate the things. Basically, we need to really collaborate between the cloud and the edge together to make your system really responsive. The idea is making your applications, making your system more responsive by doing things next to your application. Rather, we go all the way to the cloud and do everything there itself. So that's what we have been talking about by combining the big computing power of cloud with the increasingly connected and perceptive edge technology. We are creating possibilities we could only have dreamed of just a few years ago, which is possible today. As I said in the beginning, and people start talking about the cloud computing, hey, we have to go to the cloud because the cloud is offering that kind of capabilities. But today, rather we get onto the cloud, the most of the computing power can be run on premises. And that is the edge computing is all about, because it's a very emerging terms when you talk about edge computing. As I say, the edge computing may be applied to a different categories, different workload. At this moment, we'll be talking about Internet of Things, IoT. The point of discussion for today's webinar would be how the edge computing is being used with IoT, Internet of Things. So that is how we talk about the possibilities to apply the millions of connected devices And those devices every time work with the limitless data, the big data, what we talked about very often. And of course, I mean, when you talk about the millions of connected devices, of course, the millions of connected devices is going to pump a lot of data, the big data, as I say. But do you really want all the data to be stored on the cloud if I'm connecting my system back to the cloud? Sometimes the answer may not be yes. So we need to do a bit of computing after collecting data from millions of devices in on-premises, then take it to the cloud for extensive capabilities where your edge cannot offer that kind of capability. For that only we can go back to the cloud and start using this computing which is available on the cloud. But the most of the job, or maybe aggregating the data or analyzing those data, can be done in on-premise rather than doing all those things top to bottom on the cloud. So we need to create some kind of architectural or some kind of design architecture, how we are going to split the work between on-premise and cloud. At the end of the day, we need to do it. If you want to make your applications, make your system really responsive. So it is inevitable. One day we need to think about that, getting back things to the on-premises rather than every time banking on the cloud. So at this moment, under the Microsoft scope, under the Microsoft scope of technology, what I'm talking about, because this webinar is all about the Microsoft technology, including the Microsoft Cloud, Microsoft Azure. So we are not going beyond the scope. So in the scope of Microsoft technology, what are the intelligent innovations is happening? So they said something like Azure SQL database on edge. So you can bring SQL database from cloud. We know that Azure SQL database is a cloud service, is a PaaS service, platform as a service. Today, your application can make use of the SQL database as a backend from the Azure. We know that because that SQL database is a serverless computing that we can only pay what we consume, including the size of the database, including the compute power that is given to the database. All will come to me whenever I am going to use my database in a serverless context. It's a complete managed service on the cloud. And that service can be brought back to the on-premises, and which is again not only just a SQL database on the edge. So that SQL database will have a bit of AI built-in capabilities, and it's pretty interesting to see how the SQL database, Azure SQL database, it's not the traditional SQL database that we talked about, which is typically can be configured on our own on our physical system. We are not talking about that. We are bringing the managed services that is available under the platform as a service on the cloud onto the on-premises. That's number one. Number two, the IoT plug and play. Connect IoT device to the cloud without writing any code. That's very interesting. Plug and play itself. So it itself is a self-descriptive, the idea. The idea is that you don't have to write your code, you don't have to banging your head. You don't have to explore anything. The most of the things that you are going to get out of the box in context of IoT, Internet of Things. So what is basically an IoT? IoT is a combination of device and a backend system, device and sensor. So IoT use sensor, the device, to collect data from the heterogeneous context. It could be a temperature, it could be humidity, it could be a pressure, it could be a soil moisture, it could be something else. So you can collect those data continuously through the device and pump those data back to the cloud. That is a typical architecture of an IoT in today's context, because today IoT involved the cloud services, because cloud has a intelligent computing power. The data that is coming from the IoT device could be used more meaningfully to the underlying business. And that's why people took those data from on-premise to the cloud any given point in time. So in order to do that, we need to actually go and develop the entire sort of, we need to develop the entire pipeline. We need to develop the entire sort of the solutions. And today the solutions has come directly as a plug and play. So there are multiple what do you call tools, or multiple what do you call as a framework, who allow us to do a plug and play implementations in context of IoT, Internet of Things. And apart from that, so we have a HoloLens, which is basically all the tools needed to get started with the building mixed reality experience. It's a kind of virtual realities in a field of virtual realities, and a lot of workload can be built in by something called HoloLens 2 development editions. But in these sessions, we are going to focus only one, that to get an overall ideas how edge is important, how the edge become the intelligence computing field or intelligence computing platform in today's context. That is the focus point to move ahead. We won't be able to cover everything, but yes, we can pick up one, the middle one, that is IoT plug and play, and talk about how edge is important in today's context that I have been speaking from the beginning. So continue with IoT plug and play. I would like to take you back to the few background that I want to give you. So as I said, there is a natural balance in between the cloud and the edge. This is how we need to understand. So if I'm talking about in context of IoT, Internet of Things, the things is basically nothing but your devices. It may not be only devices, the things can be your car. You can collect data from your car. You can collect data from your, the truck. You collect data from your building. You collect data from any kind of environment. So these are the things which is typically connected to the internet backbone, who can pump the data. So when the things collect the data, they will go and upload, or they will produce, or they will publish those data back to the cloud. Now, who will take this data? The data is being received at cloud gateway. So there may be a service name called Azure IoT Hub. Is a one service who's supposed to receive the data that has come from the underlying devices, underlying things, what you can see on. And what is IoT Hub supposed to do? IoT Hub maybe, talk about, okay, I collect the data, now what next? What need to be done? So I can create a route on my own saying that now from IoT Hub, data will go into a particular service who will take the data and start analyzing those. And after analyzing the data, that is all about insight. After analyzing the data, it can go into actions. Actions means, yes, if I need to take an actions on the incoming data, let me take it by calling another service, by calling another system. And that's how we complete the entire pipelines, right from the collecting data and taking actions on this data any given point in time. So the point again, for getting the data on the gateway, getting insight from the data by using some kind of analytics computing power which is there on the cloud, and then again taking an actions by calling another service from the cloud. It's a complete cloud computing, intelligent cloud computing, what we are discussing once the data arrived, once the data comes in into the IoT hub. But what Edge is talking about today? So can't I get an IoT hub near to the device? Can't I get an insight, the analyzing power that I supposed to use from the cloud? Can I get it? Can I get it from Edge? Can I get it from the on-premise where my device is located? That is the point that we are trying to make. So yes, we can get, we say that yes, I can get insight, I can get all kind of actions that I want to perform. By going onto the cloud, I can get it today near to that device, near to the things that we talked about. So insight and actions as an intelligence computing has come back to the edge. So you combine cloud plus edge together to make your system more responsive. That is the bottom line that I'm speaking on. So in the context of the IoT and the edge, context of IoT and the cloud and the edge is working together by putting their own best of facilities to the end user, to the end subscriber. So IoT in the cloud, like remote monitorings and management, merging remote data from the multiple IoT device, infinite compute and the storage to train machine learning and other advanced AI tools that is available on the cloud. But IoT on the edge side, offline operations, privacy of data, protections of IPs, pre-processed data on premise, like video stream, low latency, tight control loop require the near real-time response, protocol translations, data normalization, all is being done in the edge before they send them to the cloud. So there are a lot of housekeeping work, not only just the housekeeping work that need to be done on on-premise, maybe sometimes that you need to work with the intelligence computing, and you can get them back onto the edge on the data that you want to perform those intelligence computing any given point in time. And it would be a completely consistent environment that you are going to present, you are going to see. So bringing compute to where the data is, that you can see that all of them basically working under a technology called containers. I don't want to go into the detail of the container at this moment. There would be a separate session that we may know about container. Here I'm talking about a Docker container. So the container where we can run a module like data collections, machine learning, and sending an alert to the subscriber of the data, and so on and so forth. And today, this container, what we are talking about, can be run on the edge devices. So essentially, we are running those containers with some kind of compute, with some kind of compute intensive job. And that compute intensive job has come back to the edge today. So essentially what I'm saying in a one line, that I would be able to execute, I would be able to run those containers till some time back. It was running on the cloud, but today I'm running on premises. So I'm getting things more faster because it is running on the same device who's supposed to collect the data, who's supposed to connect with the sensor. So sensor is directly giving data to the edge device, and edge device is going to process those data. Rather, it gets pumped into the cloud and processed on the cloud. And before it get processed on the cloud, I can process it on premises with the same computing power that I usually run on the cloud. Today, I'm running on the on-premise. So the question is that how this edge computing is going to be made available to me. It's all about technical component, the technical component. When I say, oh, what container I was talking about in my previous deck, it's all about a compute power that I want to run inside a container on the edge devices. But what we need the edge devices to run those containerized module or run those containerized intelligence computing unit. So we need some kind of a runtime that need to be installed. That is inevitable because the runtime who understand all the cloud computing that I was talking about to run on top of the edge device, that need to be understood by the device itself. So how the device is going to understand those computing by just putting an edge runtime. So we need an edge runtime to be installed on the edge device. That's number one. And then once the runtime is available, and then we can run all kind of inside and actions on the edge device, what you see on the screen, and start sending telemetries back to the IoT hub on the cloud for the final destinations and for the final outcome or for the final processing. So the Azure IoT Edge runtime is all about install and update workload on the devices, maintain Azure IoT Edge security standard on the devices, ensure that IoT Edge modules are always running, report module to help to a cloud for remote monitoring, facilitate communications between the downstream leaf devices and the IoT Edge devices. Suppose, for example, you may have multiple devices that is connected to the edge devices. And those multiple devices would be called as a leaf devices. These are leaf devices. And that is getting connected to the main devices, the edge devices. And edge devices is also facilitate the communications between the module on the IoT edge devices. That typically done by the Azure IoT runtime, edge runtime. And again, facilitate communications between IoT edge and the device and the cloud. The total communications, what we are talking about, also being done through the Azure Edge runtime, what we are talking about. So you need to install the workload on the device. You need to implement the security on that particular device. how we are going to send the data to the cloud. You need to ensure that the modules, like insight is one module, action is another module, they are up and running on the edge device. You should be able to monitor those modules. That is something called help to the cloud for remote monitoring. From the cloud, you should be able to monitor those modules. So whether this module is running on top of the edge device or not. If there is a difficulties, you should be able to get them on the cloud dashboard. The dashboard need to give me an alert saying that, yes, this module is not working at this moment. So you have a complete control from the cloud on the edge device because they are interconnected. All the things are running on the edge, but you can control from the cloud. It's a two-way communications that we are going to see in the implementation of the IoT ecosystem. It's not only device to cloud, the cloud also go back and give instruction to the device of what need to be done in any given circumstances. IoT Edge Hub, it's an offline support, so we can put the hub back onto the IoT device, also IoT Edge device also. This is also possible. So we can act, because typically the IoT hub is a cloud component. I can get that cloud component onto the edge runtime, onto the edge device, what we call as the edge hub. So it means the collection of the data from the multiple device, multiple equipment can be done by the hub which is sitting on the edge. Then collaborate all of them together, then send them back to the actual IoT hub which is there on the cloud. So typically, so those devices can be working with their local area networks, connected to the edge devices. But finally, when you pump your data from the edge hub to the cloud hub, so you'll be using the internet connectivities, the public internet to send the data from the edge device to the actual cloud IoT hub. And as I said before, also, we don't need to go into a look into the technical detail of this. All right. So once again, let me share the screen, I think. So I have already explained that, how the modules from the IoT edge device is typically do the intercommunication. So we do not need to go into the technical detail of that, but yes, when we are running those isolated computing on the edge device, how they're supposed to communicate, that is also important. So it is all about a path that one module is going to talk to the other module. The telemetry is coming from the IoT device. Telemetry is all about data, which is coming from an IoT device to the module called telemetries. Then what that module is supposed to do? Maybe that module will pump the data to another module called insight. So data coming from telemetry to insight to an actions. But that is not happening on the cloud. That is happening in the edge. This is all about IoT edge device, you can see. So intercommunications between the multiple modules, the intelligence edge computing, what we are talking about, is beautifully managed in the edge device with the help of IoT edge runtime. So capability of all interconnections or intercommunications between the module is being exhibited from the Azure IoT Edge runtime. So with that, there are few more components that how this edge intelligence computing is working together. So you can see that on top of Azure IoT Edge, you are running a module, the sensor module. The sensor is basically responsible for collecting the data and then send it to the IoT hub. That is the one module that we talked about. So with the help of IoT Edge isn't that you can talk to the IoT hub on the cloud kind of things. So these are the different modules. Again, I said we do not have to go module by module at this moment. We just can walk through about the modules. These are the different modules that I can see. So only one thing that we need to know technically here, these modules are basically a containerized module. When I say containerized module, mean these are all Docker based module. Essentially, this is all about Docker images. We talk about in the previous screen is saying that, okay, you need to get that Docker image from the ACR as your container registry, where you can find all the modules. If your modules are private, if your modules are, custom module that you can put it into the ACR as your container registry. Otherwise, you can get modules from the Microsoft repository as well. But yes, this module, what I'm referring to, that we're supposed to run on the edge device is all our containerized module. Because the containerization is one of the innovative solution in today's context in order to run your application and code in a form of microservices. And the same technology is being implemented by the intelligent edge in today's context. So all the modules are full of computing power is being designed to run inside a container. And that is what we talk about, the Docker containers. Docker is a technology who allow us to run container on the underlying platforms, whether it could be a Linux devices or whether it could be a Windows devices. But we can run container on top of Linux and Windows devices at this moment. So that's why we say the definition of the module is instance is a specific unit of computing running on the modules image on an IoT edge device. So that module is going to be started by the IoT runtime, almost like an operating system, your IoT runtime, IoT edge runtime. So operating system responsible for spinning up a process or spinning up an instance of a particular module here on top of IoT edge devices. And the last point all about, tomorrow, if I think of, as I said, that those module can be brought into your IoT edge device from the ready-made repositories that is being developed by somebody else. But tomorrow, if you think of developing the module on your own custom module, what I'm talking about, we can make use of your favorite development language and tools like C#, C, Python, Java, and Node.js to write the modules that you want to bring in to the edge device and make them up and running. So your technical skill from the C# or a Python or Java or a Node.js allow you to write your own modules. And that, as I say, that can run on edge device anytime from now. Now, coming back to this, that was a background that I have given about the edge, intelligent edge that I am talking about, because we are bringing the cloud computing back to the edge, and we are running on the edge devices by providing the edge runtime, and how we are running those intelligence computing in a form of modules, and that is going to run inside a container. So this is the information that we have at this moment. So we are just trying to figure out the underlying ecosystem, which is incrementally building in front of us. We are going by the component that is required for the edge computing that we have been discussing. Now, coming back to the plug and play about the intelligent edge computing. So one of the implementation is all about IoT plug and play. So what exactly the IoT plug and play is going to offer? So I said in the beginning also, the plug and play is a self-descriptive. I don't have to go to the details of the plug and play. Plug and play is that I don't need to write, I don't need to explore, I don't need to go and build things on my own. If I want to do something, I have a ready-made out-of-box component. I simply get into my solutions and play with that. I'm done with this. But while I'm using a plug and play, we need to see the context, under which context that we are using that. That is really important for all of us. So moving with that plug and play, what exactly this little bit of background information about plug and play, and then I will go and see how practically that could be assigned, or how practically that could be executed on our devices. This is what we are going to see. But when I say IoT plug and play is enable solutions builder to integrate the smart device with their solutions without any manual configuration. So that is something plug and play is all about. At the core of the IoT plug and play is a device model that a device uses to advertise its capability to and plug and play enable application. So essentially what we are saying, I have a device in on-premises, and the job of the device to collect the data and send it to the cloud. And in the backend system, whether it may be on the cloud or whether in on-premises, that backend applications, what we are referring to, can simply plug and play which is being exposed, which is being published by the device. It's basically nothing but a device model. Device model that a device used to advertise its capabilities. What can be done from that device? The device itself will go to and tell rest of the world that I'm capable of doing this. These are the functionalities I'm ready to work with. Now it become easy to the other applications. Simply so, if you can deliver this, so let me use one of them. Just use it from your plug and play enable application. So plug and play enable applications that we need to go and build to get the features, the model that we talked about. So model is the core out here. How a particular device is going to expose their capability, that is written in the model. So we need to go and supply the model. And other end, my plug and play application is going to subscribe the model and start working with those capability that is exposed by a core IoT plug and play. So this model is structured as a set of elements and that are defined as a properties, as a telemetries, and as a command. We are going to see all three of them. What is the component of a plug and play that has come from a particular model who designed a plug and play? But the core of the plug and play, as I say, the plug and play is a capability who can expose the device capability, what the device is offering any given point in time. And the other end application can subscribe and make use of those capability on the fly. So what about property that represent the read-only or writable state of the device or other entities? For example, a device serial number may be read-only properties, and target temperature on a thermostat may be writable property. So I can change the temperature of a thermostat. I said the current temperatures that has raised by the thermostat is 10 degrees, but I want to make it 20 degrees. I should be able to write that property and give an instruction to the thermostats to maintain the temperature of 20 degrees. Telemetries, that is the data written by, emitted by the devices. Whether data is a regular stream of sensor reading or an occasional error or an informations of message. These are all coming under the telemetries. And then finally the commands that describe functions or operations that can be done on a device. For example, a command could be reboot a gateway or take a picture using the remote camera. That can be done from the command itself. So I'm sitting in front of an applications, and applications can raise a command. Application go and fire a command. They go and take the photo of that particular person who is coming on that particular time, something like that. This is a command that is given back to the device, and device will obey that command. Device will go and execute the command. As I said in the beginning, it's all about two-way communication between the underlying IoT applications and the actual device who actually performing the task in a day-to-day basis. So again, I'm saying that the plug and play is one of the emerging area under the IoT implementation who involve the cloud computing. And it is a combinations of the two, the edge device, what we have been talking about, that's number one. And number two, it is all about making flexible to the end subscriber of the IoT developer or IoT architect, saying that I don't need to go back and write those code on my own. That can be simply produced from a model that is associated with the device. And the rest of the world can subscribe to the model and start acting on those, start using this model's capabilities, what we are looking at, like properties, telemetry. So we are going to see these three properties, the three components, and how we can interact, how we can make use of these three components in the IoT plug and play. We are going to see in some time. So when we're coming back to the IoT plug and play architecture, so we get to see this is the IoT plug and play architecture, what we are looking at. So you can see in the middle of everything, you have the IoT hub. an IoT hub can route my data. That is called routing rules. That route, when the data is going to be received by IoT hub from the gateway or a direct device. There are two things can be connected. The two things can be connected to the IoT hub. One is the direct device, which is basically an internet-enabled devices, and that can directly connect to the cloud and pump your data to the IoT hub. Or you can set up an IoT edge gateway device. So the point of using the IoT edge gateway devices means you may connect it with some low powered IoT devices who do not or were not enabled with the internet. And that's why they connect directly to the cloud IoT hub. So they will connect via IoT edge gateway device. So as you can see, IoT edge gateway device has one leaf device. So gateway device will take the data. An IoT plug and play module is running on this gateway, and who will basically go and send the data to IoT hub. An IoT hub can take the data and send it across to the cloud service for monitoring, for processing, or maybe some kind of backend solutions to do some kind of operations on the digital twins. Digital twins is all about, the model that I was talking about that represent your IoT devices. Or that can be given back to the web application UI to present those data in a form of graph, in a form of dashboard. Or you can put this data back into the repositories. The model and interface all would come in the DTL. So if you want to go and see kind of the model repository is a store for model and interface definition. That is called DTDL, Digital Twin Definition Language. So as I said, what is basically a digital twin definition language? Digital twin itself is property who can represent a device. So I'm taking an example of a digital twins definition language, like what would be the range of temperatures that is being read by the devices. That would be defined in digital twin. And other properties, the properties like who is the manufacturer of that particular device, that we can get it from the digital twin itself. Okay, so I request you to mute all of them. You're not speaking. Lets you manage the model and interfaces. The model repositories has built-in role-based access control that let you limit access to an interface definition. Devices that we are talking about, the device builder implements the code to run on the IoT smart devices using one of the Azure IoT device SDKs. And you can see the list of the SDK. So that is basically, I'm just walk you through with the multiple component of IoT plug and play architecture. The device, what we looked at in the left-hand side from the architecture, what is it? And the device is programmable using one of the SDK, using one of the language that we talked about, whether it is Python or C# or C or Java or Node.js, what we talked about. And those device is responsible for connecting IoT hub securely by using some kind of security tokens that's going to be exchanged between the device and your application, I mean, your IoT hub, which is there on the cloud. And we talk about IoT Edge Gateway also in the left-hand side from the architecture. An IoT Edge Gateway acts as an intermediary to connect the IoT plug-and-play devices that can connect directly to the IoT hub because of the internet is not enabled on those devices. Maybe the devices is low-powered devices, and devices is not being designed to connect directly to the internet backbones and so on and so forth. And then IoT Edge modules let you deploy and manage business logic on the edge device. As your IoT Edge modules are smallest unit of computations managed by the IoT Edge, what we discussed in the previous one also. IoT Hub, quick definition of an IoT Hub is a cloud-hosted service that acts as a central message hub for bidirectional communications between your IoT solutions and the device it manages. Backend solutions, what we have been talking about from the architecture itself, monitors and control connected device by interacting with the digital twins in the IoT hub. Retrieves the model ID, the device registered with the IoT hub uses model ID to retrieve the interface definition from any model repositories. Uses the model parser to extract information from the interface definition and so on and so forth. So collectively, the backend solution is all about interacting with the devices, sending command back to the device, receiving information from the device. All those things is typically done in the backend solution. So backend solution is the actual solutions that you are going to present to your customer. So that solutions that I'm referring to can read property values reported by the devices, update writable properties. So initially we talked about the three different type of component of a plug-and-play properties. We talk about telemetries and a command. So all can be operated from the backend solutions. And that is also we are going to see what would be my backend solutions and how we are going to go and make use of it. So now time for demo. I just wanted to give the kind of demo okay, so I get a message. Can you repeat the same? Yeah, so I don't know what point that you have asked me that questions, but yes, I'm just explaining that. But yes, so if you have any questions, so you can go ahead with the questions. So once we are done with the complete demo. Yes, so net, before I get into a demo, what is basically we have learned so far. So let me just quick recap. We have been talking about two components. So one is called edge and one is called the cloud. So we have edge is basically nothing but your device who can connect to a sensor and the device can have your all type of runtime and the modules that we talked about, where we can run the intelligent cloud computing stuff. And then it is getting connected to the cloud. And we have something called IoT hub. So data coming from those sensors would be aggregated on the edge device, would be compute bit of on those data and then set the ultimate one. And there would be a solution. And that solutions can read everything, what has come from the device, and solutions can go and interact to these devices. They can update the properties. They can send a command. They can receive telemetries, all that solutions. And the solutions that we are talking about, plug and play solution. Because the solution is going to get everything that is exposed by this device in a form of model. So only this 4 component that we have been discussing under the context of IoT plug and play. And the solution is your extensible solutions. You would be develop your own. You can get some ready-made solutions. So who's supposed to subscribe to the plug and play and start working on those components which is being offered by the plug and play, like telemetries, properties, and command. So to implement this entire system, implement this entire ecosystem, what we are talking about, right from the device to the IoT hub, and from the model, and then the solutions that we need to just walk you through with all the steps that possibly can give you an insight, possibly can give you some kind of real understanding what I have been talking for last 1 hour. So I guess everyone is aligned with me to understand the concept, the core concept of the plug and play in context of the edge computing, in context of the intelligent edge computing, what we are discussing. The bottom line is one only, that our edge, our on-premise device become more intelligence, that I don't have to go to the cloud for everything. For computing, I can get the cloud computing back on my devices and I can play with them anytime from now. Why I'm doing it? Because I want to make my system more responsive. Rather we go all the way to the cloud, I want to take it back to the on-premises for the day-to-day computing that I'll be doing in the near future, that needs to be presented by the device itself for any kind of business domain where the IoT is getting implemented in today's context. The IoT is not something new to all of us. The IoT is there for quite some time, but the innovations in the field of IoT is becoming pretty interesting day by day. The IoT is getting involved with the artificial intelligence. IoT is getting involved with the edge computing. You know, all those things is happening in the field of IoT. But as I say, the IoT is not something new technology today we are talking about. We are talking about the innovations in the field of IoTs, which is being complemented by the cloud platform. And that is the point that we are working on. That is the point that we are discussing. So as you know that we are always get in touch with the emerging technology, what is happening around us. So we have been collectively going with multiple emerging technology in every Saturdays that you can see. But at the same time, we have to come back and start implementing those emerging technology, which is generally available at this moment. So I want you to go back and start implementing, start thinking your workload, your area of working, and if it is relevant to your work areas, if it is relevant to your, kind of implementation area, please go and start using them. Please go and start implementing them. Then you will get the real kick of what we have been explaining so far. So let's get into the demo from this point. I'll be taking it to the my development machine. So I'll just back there.
Yeah, sorry, Navajodi. Yeah.
Yes, go ahead.
Yeah, yeah. This is Bhaskar here.
Yes.
So, yeah, we are backing to the on-frame, edge cloud, where you are saying that mainly for the response units, high response units, correct? Moving
Yes.
from cloud to the edge computing.
Yes.
So, but what about these factors? No, generally we are moving to the cloud platform because of the high availability and scalability and no maintenance. That is the main things we are moving. But no, now you are talking about keeping the 50% of intelligence of Azure in the on-prem itself. What about those factors? How we are going to manage those stuffs?
Yeah. So point well taken, because you are basically raising a very good point. So let me appreciate on that. So coming back to the answer to your query is yes. We are not saying that the on-premise can facilitate the kind of high availability that is being given by the cloud platform anytime from now. Okay, so that's number one. But what we are talking about as an edge computing in this context, the edge computing is typically saying that you go and get and run a module. The module context is very small. And where this module is going to run in a virtual appliance, maybe your local system. So the question is that how this module would be built to consume the compute power that has come from the on-premise. That is the question. So in typically, if you want to run a module, the containerized module, what we are talking about, it can be run on a typical your physical machines that you are using in a day-to-day basis. You don't need to go and get a very big server machines where you want to really run those modules, because those module is going to run inside the container. And a typical process that is typically running on top of a typical operating system, it is really enough to run those module as well. So that's why the module is not going to demand that big kind of infrastructure, big kind of, the resources that is required to run this module. That is number one in point of availability, point of resource, scaling up your resources. But high availability is something that you need to take care of that device or that virtual appliance to make it highly available. Either you can make it a bigger resources or maybe multiple resources. You need to invest on that, because you are bringing the compute back to the on-premise, because ultimately you want to make your system more responsive than all the way going into the cloud. So you need to estimate in that context how big the infrastructure that I have to set up in order to run those modules in on-premises. But we are not saying that the cloud is, or Microsoft is not saying that you can bring everything what typically you run on the cloud to the on-premises. So which is very pertinent to the IoTs, like, running an analytics on on-premises, running a, kind of IoT hub in on-premises, running a storage on an on-premises. But this is limited to that particular workload only. It is not like unlimited. It is not for public cloud, like everybody can come and make use of their resources. No, not like that. We need to estimate, we need to figure out that, how big the resource would be and how we make that resource highly available for my devices. If the device is offline also, it doesn't matter because you need to collect the data. You need to store somewhere. Ultimately, you can pump it to the cloud when you get your connections and when your device is up and running. So that's how you have to figure out.
Yeah, thanks.
Okay.
Thanks. No, I understood. Yeah, thank you. Yeah.
All right. So the quick one, we're supposed to do a couple of things like this. So I'll go and get. And I assume that you have the kind of bit of knowledge on the cloud platform. So I'm just going and getting into my Microsoft Azure portal. And I am going into this cloud shell from the top right corner of my portal. This is the management portal through which we can create, delete, update cloud services. So we are going to create a couple of services there. First, I'm going to create a resource group by the name of my plug and play resource group in the central US. This is just a simple statement. And then I'm going to go and create IoT hub. That is called IoT hub again. Inside that group, what I have been talking about with 2 partitions and all. So once I'm done with this IoT hub, so it is still running. So I'll just make it bigger, the screen that you can see. And then I'm going to go and create the another one. This is basically called as, before I send data from my IoT device, I need to register the device on the IoT hub. That IoT hub need to recognize the device that yes, that device is going to send the data. And who is going to register? There is another service called DPS. It's called Device Provisioning Service. So we'll go and create that also. And after that, we are going to get the connection string of that IoT hub by using a command. We are initializing this connection string into a hub connection string from the IoT connection string from the hub that we have created. That is also running device provisioning. So here said there's a variable hub connection string equal to IoT hub connection. From this IoT hub that we have created on the top, and what we are looking for, we are just looking for the primary. So I'm putting in there simple command. Once we're done with this initializations, I'll be using this variable to, I'll be using that connection string to connect that hub with my device provisioning service. So device provisioning service is going to link with the IoT hub. And then we can go and use this hub connection string. This is fine, and we can see that my just a minute. Okay, now this is fine. So this is something that we just need to do, and I get it. And then I can go and connection with, I just need to see that this is a hub connection string. Is correct or not, just need to be seen there. Resource group, my DPS01 that we have created on the top. And then once this is finished, then we'll go to the IoT hub connection string can be seen from this command. I can make use of this. So it will show me this IoT hub connection string. Everything is there. And then we'll go and we can get this scope ID of the DPS, device provisioning service. This is just to see, because we are going to use those information from the solutions that we talked about. And finally, we can enroll a device. I'm keeping the name of the device is device 01. So that is the simulated device that I'm going to enroll through my DPS into the IoT hub. As I said in the beginning, that IoT hub need to know the device from whom the IoT hub is going to receive the data. So that is the linking of IoT device to an IoT hub through the DPS. So this job is done by the device provisioning service. So we have an automated device provisioning service who can provision a device in order to register the device with the IoT hub. That IoT hub can receive data from the device. And this is done by the DPS. Everything is fine so far. Then we are going to go and set some environment variables. So I'll go to my command prompt. So I'll go to a solution folder. So I have a solutions for thermostat. And in fact, I do have a folder called model, the model that I was talking about, from where the thermostat solution will pick up the data and start working against the device. So I have these solutions, I have the applications, I can open that in the Visual Studio Code. So in the meantime, I can explore that particular folder. This is the model folder, so we can go and see what is the model. It's a JSON document. It talks about telemetries. In the telemetries, we are supposed to receive the temperature. This is the temperatures that we are talking about. And another component, we talk about command. The properties command that we say that plug and play. So command is basically saying that what command that you can fire from your solutions back to the device. So telemetries, command, and the properties. This is what we get. And the properties, all of the properties that we can see under a telemetries is all about the temperature would be a properties where we can set the values and get the value from. So this is the model. So the beauty of the plug and play is that the plug and play is model driven. So what is being told in this model that can be exposed or that could be subscribed by your solution and start working with those. Okay, so in a few minutes, we are going to use this. So in the meantime, I can go and browse my applications in Visual Studio Code. I guess we have this program. So this is the application that basically go and send the telemetries to the backend application, and backend applications can subscribe to the model which is being exposed by this, and then probably you can start interacting with your device with the help of those components which is exposed by plug and play. So now coming back, that is one, that is number one. The number two, as I said, I'm done with all the infrastructure that is needed. So again, I'm saying what I did to recap. I create a resource group. I create an IoT hub. I create a device provisioning service in order to register millions of devices to the hub, because typically we registered manually our device on the hub, but we want to automate the device provisioning. So the provisioning of the device need to be done automatically on top of an IoT hub. That can be done by DPS. Is a service, the managed service. And the rest of the things, I'm just connecting the DPS to the hub, because the DPS can be connected to the multiple hubs, because DPS job is to provision the device, connect to the target IoT hub. So DPS can connect to the So at this moment, I'm connecting the DPS to the existing hub that I have created some time back. And the rest is we are just trying to figure out the connection strings of the IoT hub in order to register the device. We have given a device name also there. You can see that device name that I'm giving it sometime. That is the device name. We can go back and see now all is done. Now, finally, from my solutions, I need to set some environmental variable. The number one, the device security type is DPS. So we are provisioning through a DPS, a device. The scope ID, I can go and this is the scope ID. Sometime back, I put it here. So I can just copy that scope ID also, or I can go to the resource group, and I can find these two services. One is the DPS and an IoT hub. So I'll go to the DPS first. I get the scope ID. I copy that scope ID. I put it here for this environmental variable. And then I go to the IoT device ID name. So I have given it something like 01. If you see that, this is the name that I have given it. Sorry. So I have given sometime the device name. So you get it, the device name somewhere like this. This is fine, 01 that we said. In fact, if I want to go and verify that, so I can go to my IoT hub. So I can go into the device which is not being done, because it is going to come at the time of basically or running that application. So we'll come back and to that point at this moment by keeping this is the device name sometime back I have given. So I'll just again to tell you that this is the device name we'd like to give, we like to assign on top of an IoT hub is correct. Then we go to an IoT hub DPS device key. So let me go to my DPS once again, go to the enrollment. So here is an enrollment. All right, so we can go to an individual enrollment. We can see this is the device name. Registration ID would be the device name. So I can go and go to the detail of that. I can get that key. You can see that key. I copy that key. I paste it here. Okay, this is the key that I get it from there. And then my IoT device provisioning endpoint would be this one, global endpoint. I don't need to change it. IoT hub connection string. So let me go to the IoT hub. So here is the IoT hub. So I go to the access policies. I can find that connection string here. So I copy that primary connection string. I come back and replace that connection string. And finally, my IoT Hub device ID, just now what we have seen. All are fine, so I can just go and one by one and set this environmental variable. So number 1, number 2, number 3, number 4, number 5, and number 6. And finally, the last one. All right, so I'm ready to run my application there. So before I running this application, I'm just building my application with all those environmental variable that I set for my project. Then I am ready to run this. So I just if everything goes well, so I should be able to connect to the IoT hub and start sending the temperature. So you can see the temperature is being sent. Device is everything is fine. So it is keep sending. Now I can go back to my IoT Explorer. IoT Hub Explorer. So I'm going to run that one. And I'll go to an IoT Hub and I'll go to the connection string. And I'm going to go and add a new connection string. Okay, so I just wanted to go and create a new one. Hub 1, this is perfectly fine. So now I can go to the IoT plug and play. Then I'll go and assign the model folders that I talked about. So I save that. This is the model folder that I have given. On that basis, I'll be able to interact with my plug and play application. So we save that one. So model repository location successfully updated with that. It's the IoT hub and plug and play settings. So we can see that at this moment. So we can go back and refresh this once again. This is my connection. Just a minute. Okay, just give me a minute. So let me go back into the, once again, delete this connection. So I'll just put the another connection there. So let me stop this telemetries for some time. This is fine. So let me go to the connection string of my IoT hub. Okay, so let me go back and see once again to the perfectly fine. Just wanted to run it once again. Just give me one more minute. So let me go back to the IoT DPS, or I will go to the IoT hub once again. We'll check this device. Yes, this device is perfectly fine. That is perfectly okay with this. So I'll just go back, then copy this. Okay, so I just need to reset the whole thing. So anyway, that's fine. So what I was trying to tell you, this is connected. And if I go back to your into your IoT hub. So I just quickly show you that few things from there only, not from an application. So I can go to my IoT hub first. So I can show you that telemetries that has come in there. So you can see the message for today is 45. The telemetry message that is being received some time back. I can run this once again. My application. So application is fine, up and running perfectly. So only one thing that need to be done from the back end, from the Explorer, what I'm supposed to do once my model is being configured. At this moment, I should be able to go and again, I'll go and pick up this model folders one more time. So I just need to set that model folder successfully is done. I can save it again. So model repository is successfully done on that. So we should be able to go and sort of, see the plugin play settings, like, so in that plugin play, I should be able to get an UI, and that UI should be able to interact with my device, which is up and running. So interaction in the context of three things, what I was explaining, because I need to redo again. So only three things from this application, we should be able to interact with the device, number one. And what kind of interactions that I'm talking about? It's all about sending a command to the device, or changing the temperature, or getting the telemetries. That is the only three things that we can do from this particular one. So it's already there. So it's already here on that context. So I'm not able to fetch the data from here, but you can see everything out there once this is being connected with this particular application. So this is fine at this moment. So net one only things to be performed from these applications. Again, I'm saying, so with the plug and play, we should be able to interact with the three components that I discussed in the beginning. The telemetries, that I should be able to see the telemetries that is being sent by the device through this application. And the second thing, I can send a command saying that give me the average temperature of the last 5 minutes. That command can be given to the device, and device can get me the average temperature. The second thing, maybe, so second things maybe, so let me just try once more time so we can see the folder again, pick that files, thermostat 1. Yeah, fine. So the third one that I was saying that, so once this sending a command, and third one is all about properties. Like properties is the temperature is one property. I want to reset writable property and readable property that I talked about. In writable properties, we can go and update the temperature. So we can say, okay, from now onwards, I want the temperature to come to me, or I want the temperature to be maintained by the device is something like that, 24 degrees. So I can also set the temperature back to the device. And the device then starts sending me what I have asked for, that 24 degree of the the temperatures. So this is a kind of plug and play that, out of the box that I can set from my applications, which is basically subscribe the model that is being exposed by the plug and play. So I'll take you, that is what I will end this today's session with. That I guess this session has given some insight about edge intelligence computing in the field of IoT by using plug and play. The one component that did not work because of some internal communication, and that is pretty simple. As I said, I explained that also. It would have been just an interactions between the device and the underlying application. So with that, I will thank you everyone to for joining this session. And again, I'm saying that is all about the one glimpse of, or one simple, or one kind of a part of this implementations, but there are the huge implementations around the IoT edge computing in context of plug and play, in context of intelligence edge, what we are discussing. So once again, thank you all of you for attending today's session. Over to Manish. Yeah, Manish.
Hello, my screen is visible.
Yes.
Yeah, yes.
Thank you, Navjyoti, for this wonderful session on intelligent cloud and intelligent edge. Also, thank you everyone for joining today's webinar. This is our next month webinar series calendar. Your views on the webinar are important to us, so please share your feedback. Feedback form link is shared in chat box. Now today's special announcement. This is our this is our next webinar. You can enroll for this webinar also. This is on Saturday, 12th June, 10 a.m. to 12 noon. The complete guide to Microsoft Power Platform. Now today's special announcement, we are giving Microsoft sponsored exam vouchers to 5 lucky winners. These winners will be selected from feedback form that will be received. So don't miss this opportunity. Please fill the feedback form. Now you can easily, smartly boost your career. Simply update your Microsoft skills and certification on LinkedIn and showcase your talent to other professionals who belongs to relevant technology. So you can update your skill on your LinkedIn. Get noticed, highlight your learning achievements, help boost your career potential. So please update your LinkedIn with these skills like cloud, intelligent cloud, or Microsoft Azure, or IoT. Claiming your certification badge on LinkedIn is very simple, and these are the steps you need to follow. Thank you everyone once again. To watch our recordings, please subscribe our YouTube channel. Thank you very much. Have a nice weekend. Stay safe. Thank you.
Mm.